Okay, so let's talk about the lines shown here in graphs A, B, C, and D. So we can tell that these are all linear functions. They're graphs of linear functions. They each have a y-intercept and they each have a slope. Right? Two of them, we know the slopes are negative. A and C have negative slopes because they are decreasing from left to right. B and D have positive slopes because they are increasing from left to right. Okay, the steepness of the lines appears to vary if we wanted to compare their slopes. In D, if we start at the y-intercept, we count rise over run. So that's up 1, 2, 3, 4, 5, and over 1. That's a positive slope of 5. If we start at the y-intercept here in graph C, that's up 1, 2, 3, but to the left one, that's a negative 3 slope. So again, we can see that the slopes are all different. So all of these are linear functions. They all graph a line, but C has something that's different from all the others. In graph C, the y-intercept is the origin. The graph passes through the point 0, 0. And when we have a line that passes through the origin, we call that a direct variation. So on the front of your notes booklet for direct variation, right, we're going to write that that is a line that passes through the origin. And remember, the origin of the graph is the point 0, 0, where x is 0 and y is 0. The origin is where the x and y axis intersect. The equation for a direct variation is y equals mx. Remember, slope-intercept form is mx plus b, but in this instance, the graph passes through 0, 0, the b is 0. So we're left with just y equals mx. The constant of variation is the slope of that line passing through the origin. And because the x1, y1 is 0, 0, then when we find the difference in the x's and the difference in the y's for the slope, we end up with y over x. Okay, and that vocabulary constant of variation is just referring to the slope of a direct variation. Okay, in example 1, we are asked to write and graph a direct variation equation that passes through the point negative 3, 2 on the graph. So if I come over to negative 3 in the x direction, up to 2 in the y direction, there's one of the points that has to be on the graph. Now, I know because this is a direct variation that this line must pass through the point 0, 0. So I can go ahead and plot that point 0, 0 on my graph as well. So looking at the slope of this line in our graph, we could count the rise over run. That would be one way to find the slope. So we would rise 1, 2, and then we would run to the left 1, 2, 3. That's a negative slope because we're going up and to the left or down and to the right. So the slope m would be a negative 2 over 3. Now, we don't want to have to sketch the graph every time we want to find the constant of variation. And so we remember that we can also find the constant of variation of a direct variation by looking at the ordered pair that it passes through. Negative 3 is the x, 2 is the y, and the constant of variation is the y divided by the x. And so we see that 2 divided by negative 3 is negative 2/3. So our constant of variation is negative 2/3. So to write the equation of the line that we see in the graph, that's y equals the slope, negative 2/3, times x. That is the direct variation equation. So on your whiteboard or on some scrap paper, you can pause the video and write the direct variation equation for the line that passes through the points 4, -2. Then use that equation to find the coordinates of 2 additional points on the line. Okay, you can resume the video when you're ready to check your answers. Okay, so let's start with the equation of the line. So this is my point, x comma y. I divide the y by the x to find the slope of that line. Since it is a direct variation, we call that slope the constant of variation. We take the y over x, which is -2 divided by +4, and -2/4 reduces to -1/2. So the direct variation equation is y equals -1/2 x. When I plot that on the graph, I know that my line passes through 0, 0, because that's a point that has to be on the line of a direct variation. So one of my coordinates of an additional point would be the origin 0, 0. Another point would be if I follow my slope out, up 1, 2 to the left, up 1, 2 to the left, and there's another point at -4, +2, right? I could also use this point located at -2, 1. I could choose this point at 2, -1, and so on, right? You just want to find the coordinates of 2 additional points on the line, but you have infinitely many that you can choose from.